Hi, Rob Aldrich with Cisco Advanced Services here today to talk to you about energy efficient design and how you can structure your data center infrastructure architecture to take advantage of some of the latest thinking in energy efficient design. So let's jump into our model. What we've structured here is a 96 rack 3-zone data center which accommodates different levels of availability, different levels of electrical efficiency, and different levels of density for each of the 3 distinct zones. So we'll call these out one by one. So our first zone is a volume compute zone. This would use traditional 1-2U volume servers. We're showing a top of rack Catalyst for 4948 for the aggregation layer, going over to an end of row Nexus and Catalyst 6500. You'll also notice on the corners we're specifying in-row branch circuits that are all network manageable. So that gives you some insight into the actual power distribution through your IP network. You may notice that some of our switches cool side to side. We do this for port density reasons. And you may have a challenge in structuring an energy efficient airflow with your cooling system because of these disparate airflows with the servers going front to back and the switches going side to side. Many people don't realize, but we do front to back options for most of our switches, and for ones that go right to left, we have partners that make specialized cooling systems like this one, the side air distribution unit made by APC. What this does is it sucks cold air off the front, blows it through a hood down the side to the inlet of the switch, and ensures that your airflow stays consistent from rack to rack by passively redirecting the exhaust to front to back. Now, one of the best things you can do in a traditional hot aisle, cold aisle situation is set up partitioning between the hot and cold air. This basic partitioning can have a significant improvement on the overall efficiency of the cooling system because you're eliminating the mixing of the hot and cold air. So in this design, we're showing partitioning with chimneys coming up for the hot air. Typically, you would put this into a dropped ceiling plenum space that's already on site, but you can also put in specialized ducted returns to fully segregate that hot and cold air. Our second zone is a sand zone based on EMC Clarion. And what you're seeing here is Clarion deployed with an in-row cooling design, which we'll look at more in just a minute. And this is typically about 12 kilowatt per rack. You don't really need an in-row or close-coupled cooling design to cool these, at least in their current state, but we do anticipate the power densities for storage arrays to be increasing in the next 5 to 10 years. So choosing a cooling design like this would, in essence, future-proof you against some of those new densities that are coming out. Our next zone is going to be built on Cisco Unified Computing, UCS. This is Cisco's version of Blade Compute that utilizes fiber channel over Ethernet and is a very efficient design. Now, this, like many Blade Compute platforms, can be very dense if you fully deploy these in a space-efficient manner. So in this case, we're showing 6 5108 UCS chassis. That will draw about 21 kilowatt nominal cooling requirement per rack. And you can easily cool that with the in-row cooling design. These units can cool up to 30 kilowatt per rack, even higher in some situations. So you can be space efficient, cooling efficient, and power efficient all at the same time. And one of the secrets to the in-row cooling design is the fact that there's very little distance for the air to travel. The air is supplied locally to the front of the racks and the hot air return right off of the rear in the same manner. So you take what has traditionally been a 15 to 20 foot path for the air to travel down a cold aisle and bring that down to 2 or 3 feet. So an extremely efficient design. Now, of course, you've got to cool these. So we're showing the crack units off to the corner, and you're also going to need to power them, of course. So we're showing the uninterruptible power supplies off to the side as well. Now, there are many schools of thought on this, but we often advocate that you do not need to put in a raised floor. You can run most of the services overhead and save significant cost and also improve your airflow by not putting cabling and air under the same plenum space on a raised floor. Same with the data runs. So you can use a Whalebone system at Cisco. We primarily use a Whalebone system for data runs and power overhead. And as you can see, it looks very clean. And it's, in fact, very easy to troubleshoot a cable that way because you don't have to be pulling up tiles. You simply hop on a step stool. And then for this entire data center, we have it all going back to a front end of our carrier routing system. This system can push 70 terabits per second, all the connectivity you could ever need. In addition to what Cisco can do around infrastructure architectures, we also have some breakthroughs around energy management, specifically Cisco EnergyWise and building mediator technologies. These, when taken together and implemented correctly in a data center environment, can have significant OpEx reductions related to primary electrical use. If you'd like to see more about our services or technology around energy efficiency, please visit cisco.com/go/efficiency.